let h of x be equal to x minus 1 squared minus square root of x minus 1. Three things. First, write h of x as a composition of two functions, f composed with g of x. Then, identify the domain of h of x. Then, identify the domain of g composed with f of x. Okay, first part. I want to write h of x as a composition f composed with g of x. First step, we need to identify the inside function. Once I have that function, we're just going to set it equal to y. If anything remains in our old function, say that has an x term in it, we're going to have to do more work. If not, we have our composition. Then, if things are complicated, we might want to check our work. Now, what's the inside function here? So, you can pick your favorite number, say 3, see what happens when you stick it into your h. So, what's the first thing we do? I'll have to compute 3 minus 1 in two different spots. So, the inside function is going to be the very first thing that we do. So that's going to be x minus 1. So we'll have g of x equals x minus 1. Now, where I have an x minus 1, we're going to put a y. So I'm just going to set y equal to g of x. Then what happens? So we're going to put a y here, and we're left with h of x equals y squared minus square root of y. There are no x terms in this, so that's what I'm going to call our f. Okay, f is going to be a function of y if I have it written like this. So that's going to be our composition. We'll have, okay, we could just sub out the y with an x. So that'll give me f of x equals x squared minus square root of x. And then g of x is equal to x minus 1. Okay, if we just composed a check, that's just taking the x minus 1, stick it in for y. So it's just going to be x minus 1 squared minus square root of x minus 1. So our expression isn't very complicated, so we don't need to do any heavy lifting, but sometimes you will need to. Next step, we want the domain of h of x. So the idea is we have to figure out where the issue is going to be in our function. So if you note, if I just put an x in, what happens? I evaluate x minus 1 squared. Okay, that's not going to be a problem. I can put any x into x minus 1 squared. I get a sensible number out. Problem is going to occur when we try to put an x in for square root of x minus 1. So for instance, if you try to put 0 in there, take square root of minus 1, and that's not going to be defined. So the idea is going to be, I just have to pay attention to what's happening in this expression here. This one will always be fine, but x is going to have issues when we try to push it through here. So what are we looking for? The problem square root of x minus 1. So let's just say that's box. Okay, I'll call box equal to x minus 1. So if I have square root of box, that's only going to be defined when box is greater than or equal to 0. Now, we put our x minus 1 in for box. So it's only going to be defined when x minus 1 is greater than or equal to 0. And that's going to be the same as x greater than or equal to 1. So that's our answer. Okay, of course, you could try to test that. So you note, let's try a few points. If I put a 2 in for h, what do we get? We're going to have 2 minus 1 squared. So it's going to give me 1 squared, which is 1, minus, and then here we have 2 minus 1 square root. So it's going to give me square root of 1, which is also 1. So we get a 0. So there's no issues there, and we note 2 is going to be bigger than 1. Then if I try 1, so that's going to be right on the cusp here, what's going to happen? Put a 1 in here, we're going to have 0 squared is 0. Then I have minus square root of 0. Okay, square root of 0 is just 0. So again, we're perfectly fine. We get a 0 out. Then, if we try, say, minus 1, okay, minus 1, we get a minus 2 here. I square it, we get a 4. Put minus 1 into there, we get square root of minus 2. And then, that's not good. So for minus 2, we're just going to say undefined. Okay, that takes care of domain of h of x. How about if we compose in the other direction? What will the domain be then? So note, if I compose in the other direction, okay, you have options on how you do this. So I'm going to take f of x and we're going to stick it into g. So if I pretend there's a box here, we have g of box equals box minus 1, and then I'm just going to stick f of x into the box. Now, f of x is just going to be x squared minus the square root of x, so now I could just stick that in, and now I have to worry about where this is defined. Okay, well note, all numbers are going to pass through x squared. That causes no problems. Problem's only going to occur when we try to put a number into square root of x. Now, there's no fancy expressions here, so we just have to worry about where is square root of x defined. That's just going to be x bigger than or equal to 0. So that's going to be the domain of g composed with f. Then you could check points if you want, but we'll just leave that as it is.